Good morning, Chase. Today we're carrying on from yesterday and we're looking at section 5.9, which is the straight line graph. As you probably remember, a straight line graph has the form y equals mx plus c. This is also known as the gradient intercept form, because we've got m, which is our gradient, and c, which is our y-intercept. Okay, and now you'll remember, most likely, if we draw a straight line, the gradient is, if we draw a little triangle here, the gradient is the rise over the run, and the y-intercept is that value over there on the y-axis. Okay, so example 5 in your book, so example 5 says, write down the equation of a line. So equation of a line intersects the y-axis at 3 and has a gradient of 3/4. Okay. So the gradient is 3/4, and we know that m is the gradient, so m equals 3/4. The y-intercept is 3, and we know that the y-intercept is c, so c equals 3. And then you've got your general form, which is y equals mx plus c, so we can just pop those values in, and y equals 3/4 x plus 3. And there you go. Okay, they also talk about another general form. The general form ax plus by plus c equals 0. That's your other general form for the straight line graph. It's not very commonly used. I wouldn't worry about it, and in any case, what you do when you see an equation in this form, to get it into or to work with it, all you're going to do is take this equation and rearrange it into y equals mx plus c form. And how you do that is you just solve for y. So in this case we would say by equals minus ax minus c, and then y equals minus a over b x minus c over b. And now you know that your gradient, so here is, this would usually be m, should be mx plus c. So m equals minus a over b, c equals minus c over b. Okay, and there you go, you've got your gradient and your y-intercept just by rearranging this form that's given there. Okay, so example 6 says, convert the following equation to the general form. Okay, alright, just to get you in on the terminology, this form is called the gradient intercept form, or the gradient form. This form is known as the general form. As I said, the gradient intercept form is far more commonly used. It's far nicer. So, okay, example 6 says, convert y equals 3/2x minus 3 to the general form. What is the general form? Ax plus by plus c equals 0. So basically we just need to write this equation in this form. Okay, so let's start. Let's take our equation y equals 3 over 2 x minus 3 and get everything onto the left hand side. So y minus 3 over 2x plus 3 equals 0. Okay. So we're already halfway there. Okay. Next we want, as far as I am concerned, this answer we have here is already acceptable. Because if we compare it to that form, well, let's just write the variables in that order. So minus 3 over 2 x plus y plus 3 equals 0. As far as I'm concerned, you've already gotten it into this form, because we can now say, by comparison of these two equations, we could say a equals minus 3 over 2, b equals 1, c equals 3. But they wanted you to take it a step further by getting rid of this 2 at the bottom here. So how do we do that? We just multiply the whole equation through by 2. So that gives minus 3x plus 2y plus 6 equals 0. And there you go. You're now in the general form. I think I made a mistake here somewhere though. Why? Let me just check something here for you. Okay, you'll notice in your book, they say that the coefficient of x should always be positive. I'm not sure why. I don't think there's any real reason for it, but they say coefficient of x must be positive always. So we're just going to get rid of this negative by multiplying the whole equation by the minus 1. So that gives 3x minus 2y minus 6 equals 0. It's the exact same thing. I'm not sure why they wanted you to do that, but that's the answer they gave. So there you go. There's your final answer. It's just simple algebraic manipulation. Okay. Next they talk about another form for the straight line graph, which is the intercept form. This form tells you the x and y intercepts of a straight line. Okay. The form is x over a plus y over b equals 1. A is your x-intercept, b is your y-intercept. Okay, so basically if you had your straight line and you do it like that, this point here would be A, this point here would be B. Okay, it's as simple as that. Okay, let's take a look at the example that they gave for the intercept form. Okay, which is example 7. A straight line intersects the x-axis at -3 and y-axis at 4. Find the equation of the straight line in general form and and convert it then in gradient form. Okay, so basically they're saying you have a straight line intersects x-axis at -3 and y-axis at 4. Find the equation of the straight line in general form and convert it to gradient form. Okay, so they're basically asking you, because they've given you the intercepts, they're asking you to use the intercept form. So the intercept form once again is x over a plus y over b equals 1. Okay, and we know that a is our x-intercept and b is our y-intercept. So we can just plug in this value for the x-intercept and this one for the y, and we will have written the equation in straight line form. Oh, intercept form, sorry. Okay, so it's x over a is our x-intercept, which is -3, plus y over b is our y-intercept, which is 4, equals 1. Okay, then they say find equation in gen form. Okay, so next we need to get into general form, which was ax plus by plus c equals 0. Let me just double check that. Yes, ax plus by plus c equals 0. So basically all we're going to do is manipulate this equation to get it into this form. Okay, so let's start off by getting everything on the left hand side so that this equation is equal to 0, as in the general form. So we've got x over -3 plus y over 4 minus 1 equals 0. Okay, next we're going to want to multiply through by these bases to get rid of them, okay, so that we don't have fractions in our what do you call them? Our coefficients aren't fractions. We want them to be whole numbers or integers. So let's multiply through by -3, the whole equation through by -3. So x plus -3 over 4y plus 3 equals 0. Okay, now we multiply through the whole equation by 4 to get rid of the denominator here. So 4x minus 3y plus 12 equals 0. And there you go. We've now got it into the general form, as you can see. Okay, now then the next part of the question is write it in gradient intercept form, which is y equals mx plus c. Okay, so let's just, all we have to do to go from general form to gradient intercept form is solve for y. Okay, so let's get our y term on the left hand side of the equation and move everything else to the right. So minus 3y is equal to minus 4x minus 12. Then we want the y by itself, as you can see in the form there. So let's just divide the whole equation through by minus 3. So that leaves y equals minus 4 over minus 3x minus 12 over minus 3. Okay, and then we just simplify, which gives us y equals 4 over 3x plus 4. And there you go. You've now written it in the gradient intercept form or the gradient form, as well as the general form, as well as the intercept form. I just want to show you, for interest's sake, actually no, we'll get there later. I don't want to jump to that yet. But yeah, these are the three forms of the equation. What you should be picking up is, from the information that's given, know which form to write your equation in, because each of these forms has a like, given certain information, it's easier to write the equation in certain form. For example, with the gradient intercept form, obviously if you're given the gradient and intercept straight away, it's easier to write it in this form and then convert. Okay. The general form is just the standard form. There's no particular information that you're given there that makes it easier to write in this form. And then if you're given the two intercepts, you obviously want to use the intercept form because it's easy to write it in that form given the intercepts. Okay, let's get a blank page here and we can talk about the next piece. Okay. Okay. The next one is your point gradient form. And this form is y minus y1 equals m into x minus x1. Okay. So basically here you select a point on your line. So here is a straight line and you've got point A, which is 0.23. Okay, you use that ordered pair where this value is x1 and this value is y1. Okay, so we've got y minus 3 in this example equals m into x minus 2. Okay, then you would still need to determine the gradient. I've already done half of example 2 here for you. Example 8. In example 8, they say a line passes through, or they ask which line passes through point 2, 3 and has gradient equal to 3 over 4. Okay, so we've already done half of it. We've used the point. Now it's just important to note, say now you had a line and they gave you the points, let's call it -1, -4. For example, if they gave you 2 points, you could use either for x1 and y1, but they must belong to the same ordered pair. Okay, so you couldn't use, for example, -1 as x1 and 3 as y1. That's incorrect. You could either use x1, y1. Okay, so you can either use this point or that point, but don't mix x's and y's from different points on the line. Okay, so here we've chosen to use point A, we've subbed it in, and they also said the gradient is 3 over 4, so y minus 3 equals 3 over 4 into x minus 2. And then we're just going to write that in our point intercept form by rearranging this equation. Okay, so y minus 3 equals 3 over 4 x minus 3 over 2. Okay, then we just take this minus 3 across. Y equals 3 over 4 x minus 3 over 2 plus 3, y equals 3 over 4 x, minus 3 over 2 plus 3 gives us plus 3 over 2. Okay, and there you go. You've answered the question. They asked which line passes through the point 2, 3 and has the gradient that. So when they say which line, they're saying give the equation of the line. Okay? Give the equation of the line. You didn't have to write it in point gradient form. You could have rearranged this equation into any of the forms that you like. You could have done the point intercept form, which is the one we did, point intercept here. You could have put it in general form. You could have put it in intercept form. It doesn't matter. But in general, as I said, the best form and the most commonly used one is the, I think it's called, what was it? Point intercept form. No? Gradient intercept form. This is gradient intercept form. And that is the most typically used one. So generally you're going to write a straight line in the form y equals mx plus c. Okay? Which is the gradient intercept form. Okay. Now there's another example here, which is example 9. Okay. Find the equation of a line through the point 2, 4, which has an angle of inclination of 36,87 degrees. Okay. Also write the inverse of the line. Okay. So they've told you two things. They've given you a point 2, 4 that the line passes through, and they tell you that the angle of the line, angle of inclination, is 36,87 degrees. Now if you look at a straight line, okay, it passes through point 2, 4. 2, 4. So the line looks something like that. The angle of inclination is theta, and it's always measured from the x-axis counterclockwise. Okay, now what's important to note is that the angle of inclination is the same as the gradient. So it has a gradient basically of 36,87 degrees. But you know that the form, the gradient intercept form, is y equals mx plus c. And m needs to be a number and not an angle. Okay, so how are we going to find m? Well, gradient m equals change in y over change in x, or rise over run. If we draw our little gradient triangle, we've got delta y and delta x. Okay, so let's draw that gradient triangle a little bigger. Delta y, delta x, and the angle of inclination. Are you starting to see where this is going? We can use trig to find m. because tan theta equals y over x. Okay? And y over x is equal to m. So m equals tan theta. M equals tan of 36,87 degrees. And therefore m is equal to 3 over 4. Okay, so we've already found our gradient. Now, they've also given you a point. So basically, they've given you a point, and they've given you a gradient. So what is the best form to use? Let's run. Well, what's the best form to start with here? Well, you've got the gradient form, which is this one, y equals mx plus c. We've got m. We don't have c. Okay? We've been given a point. So this is probably not the best form. The general form, we've already said, is just a way of writing it, but you can't write it directly from given information. So we're not going to use the general form. The intercept form, which was x over a plus y over b equals 1. This we use when we're given the x and y intercept. We haven't been given that, so let's not use that form. Okay? The point gradient form is the one we're going to use, because the point gradient form is y minus y1 equals m into x minus x1, right? And we've got a gradient, it's 3 over 4, and we've been given a point. So it's going to be easy just to substitute in. So our point, here we have x1, here we have y1. So y minus 4 equals 3 over 4 into x minus 2, which was x1 from here, from our point. Okay. So now we can just rearrange this and write it in whatever form we choose. As I said, personally, I always prefer to write it in what they call the gradient form, which is your y equals mx plus c. So let's simplify this out and write it in the form y equals mx plus c. So y minus 4 equals, multiply the 3 over 4 in, 3 over 4 x minus 3 over 2. Take the 4 across. Y equals 3 over 4 x minus 3 over 2 plus 4. Y is equal to 3 over 4x plus 5 over 2. And there you go. You've given the equation of the line. See? We've answered our question. Find the equation of a line. Okay, then there's the second part, don't forget that, which says write the inverse of the line. Now remember we spoke about inverses yesterday. So let's call this f of x. Okay? And how do we get the inverse of the function? Okay, so to get the inverse, we swap x and y and solve for y. So let's take this equation and swap the x and y. So we have x equals 3 over 4 y plus 5 over 2. Okay, and now all we have to do is solve for y and we will have the inverse. So let's do that. So let's take the 5 over 2 across. X minus 5 over 2 equals 3 over 4 y. Okay, then we're going to divide by 3 over 4, which is the same as multiplying by 4 over 3. So we're going to do that across the whole equation. So 4 over 3x minus 5 over 2 times 4 over 3 is equal to y. 4 over 3x, that is 20 over 6 minus 20 over 6 equals y. Okay, and then let's just write it in standard form with the y on the left. Y equals 4 over 3x minus 20 over 3 simplifies to 10. 20 over 6 simplifies to 10 over 3. Okay, and there we go. We've solved for y. So now f inverse equals 4 over 3x minus 10 over 3. Cool. And you can write it as f inverse of x. 4 over 3x minus 10 over 3. And there you go. Now we've also got another form. This book goes over a lot of forms. 2-point form. So for the 2-point form, as it says, this is when you're given 2 points on the line. And this is the form you're going to use. So say I've got my line, I'm given the point 1, 2, and negative 3 and 1. Okay, so I'm given those 2 points. I've now got 2 points on the line, so it doesn't really matter which order you use them in. So we've got x1, y1, x2, and y2. Okay, and we're going to substitute them into this formula, which is the 2-point form formula. Y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Okay? Yeah, there you go. So let's do an example, which is example 10. It says find equation of straight line which passes through two points. Okay, minus 1, minus 3, and 3 and 1. Okay. Okay, and then I'll do the second part of the question afterwards. So let's quickly substitute in. It doesn't matter which pair of coordinates you choose as number 1 and number 2, but let's just do it this way. Y1, x1, y1, x2, y2. Okay, so let's substitute in. Y minus y1 is minus 3, y over x minus x1 is minus 1 equals y2, which is 1, minus y1, which is negative 3, over x2 is 3, minus x1 is minus 1. Okay, so now we can simplify this and write it in the gradient form. So y equals mx plus c. Okay, so let's start simplifying. I'm going to try to write nice and small and fit it on the page. Y plus 3 over x plus 1 is equal to 1 minus minus 3 is 1 plus 3 is 4 over 3 minus minus 1 is 4. So we've got y plus 3 over x plus 1 is equal to 1. Okay. So now let's multiply through by x plus 1 so that we get rid of the denominator. So now we've got y plus 3 is equal to x plus 1. Okay. So now we've got y is equal to x plus 1 minus 3. Y is equal to x minus 2. So there you go. Okay, you've solved for the function or the equation of the line. The second part of the question asks, write down the inverse of the line. So to get the inverse, remember we just switch the x and y. So x equals y minus 2, and now we solve for y, which gives y equals x plus 2. Therefore, f inverse of x is equal to x plus 2. Okay? The question also asks, is the line a function or a relation? And is the line continuous? Okay? So in order to draw a straight line, any straight line for that matter, let's just draw one here. Okay? To check if it's a function or a relation, we do the vertical line test. So we draw a couple of vertical lines, and you'll notice that each of these vertical lines only ever crosses the function once, which means it is a function. Okay, it's not a relation. If we had a case like this, for example, where you had that with one of the vertical lines crossing the function twice, then it would be a relation. But in this case, it only ever crosses once, and it's a function. Then the other question is the line continuous? Well, if you look at the straight line, I'll draw another one there for you somewhere. There's a straight line. To draw a straight line, do we ever have to lift our pen? No. We can just draw them. Okay? So, the function is indeed continuous as well. Okay, and that's the answer to question 10. Example 10. Okay. Here your book gives a nice little summary of the straight line forms. Okay. And I think this is useful for you because it's important to know all of these forms and when to use them and how to use them. Okay, so the summary. Okay, gradient of a straight line is m equals delta y over delta x equals y2 minus y1 over x2 minus x1. Okay? Next, so 1. Gradient form y equals mx plus c, where m is the gradient, c is the y-intercept. So you're going to use this form when you're given the gradient and the intercept, or you can calculate the gradient using this equation. So if you're given 2 points, you can calculate the gradient, and if you're given the intercept, then you can just pop it into this form. Okay. Number 2 is the general form, which is ax plus by plus c equals 0. This form is not particularly useful. The only time I can think you'd use it is if they tell you to write it in the general form. So that's general form. Okay. Number 3 is the intercept form. X over a plus y over b equals 1. So if you're given a line and you can see or are given the x-intercept and the y-intercept, then you can just pop it into this form and solve and convert it to whatever form you want. So this is called the intercept form. Okay. Number 4. Number 4 is point gradient form, which is y minus y1 equals m into x minus x1. Okay? So this form is called the point gradient form, and you would typically use this when you're given 1 point and you're given or can calculate the gradient. And then once again you can rearrange this equation into any form you like with some algebraic manipulation. And the last form is 2-point form, and you can use this form if you're given 2 points. You can just pop it into the equation and manipulate it to be in whatever form you like. As I said, the most useful form to manipulate into is the gradient form. You're going to probably, in most cases, want to manipulate all of these forms to look like the gradient form, unless they ask you to do it in another form. And the formula for the 2-point form is y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. Okay, and alright, the important thing about this form is that the 2 points you're given, remember that the subscript 1 and subscript 2 must belong to the same ordered pair. So if you've got 2 ordered pairs, you can have x1, y1, x2, y2, but never mix your points. So never say x1, y2, x2, y1. Okay? Don't do that. Okay. So it doesn't matter which ordered pair you select as x1, y1 and x2, y2, just as long as x1 and y1 belong to one ordered pair and x2 and y2 belong to another ordered pair. Okay, so that covers all of the general forms of the straight line, or all of the forms of the straight line and all of the ways to manipulate them. And yeah, we can, so I'm going to end the video here, and yeah, we'll continue with straight lines in the next video. Thank you very much for watching. Cheers.